Hey geometry team, and we are back to our second half of our midterm review walkthrough. We are on the board now instead of working on paper for technical difficulties, so hang in there. We'll get through this. Hopefully you have your paper in front of you and we can still get things set up. So starting over here with problem 17, I'm trying to find the measure of x, and I have that this angle is 52, this angle is 43, and I'm just trying to find x down here. So the knowledge you need to use here is that the angles in a triangle add up to 180 degrees, our triangle sum theorem. And so we're going to take the 52 degrees, add on the 43, and add on the x, and together all three of those things should equal 180. And so let's go ahead and simplify this equation now. 52 and 43, so that's going to be 95 plus x equals 180. And when I subtract it out from both sides, x is going to equal 85 degrees. Okay. This problem in the middle is set up slightly differently, but it actually uses the precise same theorem. I have a triangle. I know that I want to find x, but they didn't tell me how much all these angles were. But we can still use the same property. I can still say that these three angles have to add up to 180 degrees. So I'm going to take my 3x and my 2x and my x and still add them all up to 180 degrees. When I do that, 6x equals 180, and I can divide out, and x should be 30 degrees for this guy. And you can always go and plug that back in and check. If you don't trust my math, go and check it. You don't have to believe me. You can always do stuff like that in math. This last guy now, I've got x plus 5, 2x minus 2, and a right angle. And there's a couple ways you can approach this one. One way to do it is to just say all of these angles add up to 180. This one's 90. So I could do the 2x minus 2, add in the x plus 5, and add in the 90, and equal 180. Okay? That's one way to tackle it. Another way is to remember that in a right triangle, these two angles together simply add up to 90, which is what you would get if you subtracted the 90 from both sides here. So you could have started on the second step of this and started off with the 2x minus 2 and the x plus 5 being added to make 90. Okay? And either of those would be acceptable because they get you to the same place. The second one just lets you skip a step because you remembered this property. So moving forward from here, I'd have 3x plus 3 equals 90. And if you subtract the 3 from both sides, 3x equals 87. And then x is going to end up equaling 29. Okay? So that's using the triangle sum property for all of these different guys in a bunch of different ways. Okay? So now that I'm up on the board, I'm going to have to take time to erase stuff and move papers around. And you're just so thrilled. Let's move you up, fellas. There we go. All right. So now I'm still trying to find angle x, and I'm just going to be using the properties I have. I know that this guy is x, this guy is x, this guy is 43, and this one is 57. Okay? And so to figure this one out, I'm going to focus on the triangle that has stuff that I know first. This one has 43 and 57, so I can use the triangle sum theorem, and I'm going to call this guy question mark because, why not? And that all adds up to 180. And so when I put all this together, 43 and 57 is 100, plus my mystery angle equals 180. So this mystery angle in the middle must equal 80 degrees right here. But if this guy is 80 degrees, it's vertical angles to the angle over here, so this one is also 80 degrees. So now we've branched out into using something else to find our angles. Now we've used the vertical angles. And so now I have this guy is 80, and these two together, all of those three have to add up to 180 now. So I'm going to have my x plus my 180, not 180, Mrs. Cerna, just 80, those 3 right here add up to 180. So now I have 2x's plus 80 is 180. So when I subtract that out, 2x's equals 100 and x is 50. So for this one, you had to know several different properties and keep it all in your head all at once and know which tool to pick out of your bag to solve your problem. Okay? Next problem. I again am trying to find x. It's out here, and I know that this angle right here measures 44 degrees, and these two are congruent. Okay? I'm going to call these guys y, just for giggles. So this one's y, and this one's y. Now I know that these 3 angles have to add up to 180. So I know that 40 plus y makes 180. And so 40 plus 2y is 180. Subtract out that 40. 2y is 140. I was thinking 40 in my head, but my hand wrote 180. So frustrating. And then you divide by 2, and y is going to equal 70. And so I know that these two guys are 70. Is that 44 and all this time and I wrote 40? Mrs. Cerna, you guys were probably screaming at the screen. Mrs. Cerna, you're messing up. The students in class physically know what that's like. They see it all the time. Let's try this again. So I have 44 plus y has to be 180 to add up for this triangle. So 44 plus 2y is 180. Subtract out 44 this time, and 2y is going to equal 136. And when I divide it out, y is going to equal 68 degrees. So there, I fixed it. The world did not end. We've got 68 degrees there. But wait, that's not what I was supposed to find. I'm supposed to be finding x. And so to find that, I'm going to have to use the fact that these two angles are a linear pair, which means these two angles, x and y, add up to 180 as well. So I can say x plus the 68 equals 180. And when I subtract out the 68 from both sides, x is going to end up equaling 112 degrees. All right? And now I'm kind of running out of room. Let's see if I can just scoot you over here a little bit and not have to erase yet. Okay. For this last guy, I'm looking for my little angle x right here. I know that this guy is 21 and this guy is 34. And I need to find x. Now, I could use the same property I used over here and find what this angle is and subtract it from 180. Or I could use my exterior angle theorem, recalling that this angle on the exterior always equals the sum of the, I can't even remember the name of it, but the other two angles in the triangle. Okay? And so I could say that x equals 21 plus 34. It just equals those two added together. And so x has to equal 55 degrees. And again, you could have done that the long way, adding to 180 and subtracting. I like to take the shortcut. Moving forward, clean off some board here. Now let's switch out a paper. So here's where you get to be an artist. So the first one says, draw a median and explain how you know it's a median. So for a median, remember, median sounds like middle. So a median is going to connect a vertex to a midpoint. Okay? So I'm going to have this, and then I'm going to be connected to my midpoint here. And so I will draw that and make that my median. How do I know it's a median? How can I show that in my picture? I can show that by showing that medians will cut the other side into congruent parts. So if I mark those as being congruent, then I have shown that this segment goes from the vertex to the midpoint. And you can write this all out in sentences. I'm not going to waste my time because I'm saying it out loud to you. So medians go from a vertex to a midpoint, which you have to show by seeing congruent parts. That also tells you that when you're on something, if you see congruent parts, then you know you have a midpoint and you're happy. Cool. Moving on up. For this one, it says draw a perpendicular bisector. Now for a perpendicular bisector, I'm going to need to draw something that's perpendicular. Well, perpendiculars make right angles. So I need to draw something that makes right angles. And it's a bisector. So I'm going to need to draw something that bisects something. And remember, bisecting is like a midpoint. It makes two congruent parts. So I need to go from a vertex, and I need to, well, not from a vertex. Scratch that, I didn't say that. I need to draw a segment that bisects one of the sides. And so here's a side, I'm going to say it bisects, that looks like about the middle. So if it bisects it, it's going to cut it into two congruent parts. I also need to be perpendicular. So the line I draw from here isn't necessarily going to go to the vertex because I need to make it be perpendicular. I need to make it have right angles. And so I'm going to very carefully try and draw this as straight up and down as I can from that line and mark that it made a right angle there. That way I have a line that is perpendicular and bisects the side of the triangle. Okay? And so make sure you're meeting both of those criteria for perpendicular bisectors. Our last one is going to be an altitude. Now an altitude, kind of like your height, is always measured straight up and down perpendicular to the ground. So here's another one that's talking about being perpendicular. So we need to make sure that it makes right angles. So right angles. So I need to, this one does start at the vertex, and I need to make a line that goes from here to this other side but makes a right angle. If I were to take it down here, that wouldn't be a right angle. So I'm going to look for an opportunity to bring it to this other side and make a right angle. And that's what makes my altitude. The difference between this and the perpendicular bisector, altitudes do not have to bisect, and altitudes do have to go from the vertex to make that right angle. Perpendicular bisectors do not have to. They do sometimes if you happen to have an isosceles triangle, but they don't always. So keep that in mind so you're not tricked by the special problems that seem to give it all away. Okay? For this guy now, draw an angle bisector and explain how you know it's an angle bisector. Well, its name gives it away. It bisects, so it makes two congruent parts of an angle. So I need to take an angle and cut it into two congruent parts. So I'm going to take this guy, could take this guy, could take this one, doesn't matter, they're all good. But I'm going to take this one, and I'm just going to eyeball what looks like to be cutting it down the middle. And then to show that I have decided that those are congruent, I'm going to mark that those are congruent. And this makes this segment the bisector of this angle on top. Next one. So I have triangle GJH, and DE and F are all midpoints here. And so if they're all midpoints, this is a midpoint, this is a midpoint, and this is a midpoint, this means a couple of things. First of all, if it's a midpoint, those are congruent, these are congruent, and these are congruent, because midpoints cut into congruent halves. The second thing we know then is that the segments connecting those midpoints are called mid-segments. So here are mid-segments here. Okay? Now it says DE, so this blue guy I just drew, is equal to 4x plus 5. And GJ, so this whole length here, is going to be 3x plus 25. And I need to figure out how much DE is. So I need to figure out how long that little piece is. Well, here's where you need to remember your mid-segment properties. These mid-segments were special because since they connected midpoints, this piece is always going to be half of the side it is parallel to. So however big this is, it takes two of them to make this guy. And then the other thing, of course, is that they are parallel to the side that they don't touch. And so I'm going to use the property there to figure out how big DE is. So this mid-segment here is half this guy, which means it takes two of these to make one of these guys. So 2 of that 4x plus 5 is what it's going to take to make 3x plus 25. Now the other one, you could have set it up by just saying half of the big guy equals the small guy. Both of those are equivalent statements. They both end up doing the same thing. I'm going to work with this guy because that's the one I wrote nice and big. To solve this, I'm going to distribute and have 8x plus 10 equals 3x plus 25. I'm going to get all my x's together. And while I'm at it, I'm going to get all of my numbers together. Okay, so I just combined two steps into one. 5x equals 15. If I divide off the 5, x will equal 3. And you think, great, I'm done, but you're not, because I still have to find the length of DE. So to find the length of DE now, I'm going to take this number and put it back into what the length of DE is. So I'm going to have 4 times my 3 plus the 5 will give me the length of DE. So 4 times 3 is 12. And then 12 plus 5 is 17, which gives me the length of DE. All right. If I had worked this guy, would have gotten the same answer. That's the beautiful thing about math. Lots of ways to solve the same problems. And we are rocking and rolling all the way to our next unit. Here we've got special right triangles and trigonometry. So I know you guys miss doing this. So here I'm going to solve for x and y. I've got a triangle with a 45-degree angle, a right angle, and so I know that this other guy must be 45 in order to add up to 180. I've got y, x, and 2 times the square root of 6 for my pieces. So I immediately need to recall the ratios that we did for my 45, 45, 90 special right triangles. So if you have a side that's an angle that's 45, another angle that's 45, and another angle that's 90, I know that the 45 and the 45 are going to be congruent legs, whatever they are. So the side opposite this 45 and the side opposite this 45, they're actually going to be congruent because this is an isosceles triangle. Whenever you have congruent angles, you have congruent sides. And then the hypotenuse here is going to be the leg times the square root of 2. Those are the ratios that always work. So now I set up and go, okay, well my hypotenuse was 2 times the square root of 6. One of my legs is x and the other leg is y. Now you have the information you need to start finding the numbers you want to do. So this right here tells me an equation I can set up. My hypotenuse is the leg times the square root of 2, and I know that it's 2 times the square root of 6. So I can say that leg, whatever the leg is, times the square root of 2 is going to equal to 2 times the square root of 6. So let's get that leg by itself. It's times by the square root of 2, so I'm going to divide off the square root of 2. And that's going to give me my leg, however long it is, will equal this guy. Let's simplify this radical fraction here. Well, remember, I can divide these. So the square root of 6 divided by the square root of 2 will give me the square root of 3. Anything under the radical can get divided under the radical. And then that 2 is going to hang off in front there. So my leg is equal to 2 times the square root of 3. So this is 2 times the square root of 3. And this is 2 times the square root of 3. Knowing this and having this memorized, remembering your ratio here, is going to be the most important thing you can have for solving these special right triangles. Okay? Next one. So here again, I'm going to solve for x and y, and I have another 45, 45, 90 right triangle. I've got y down here, I've got x on the hypotenuse, and I've got 3 square root of 2 over 2 as one of my legs. Since it's a 45, 45, 90, I can set up my ratios, and I write this every single time so I don't mess up. So I'll have 2 legs, and then the hypotenuse will be the leg times the square root of 2. Now, okay, in my triangle, my hypotenuse is labeled as x. One of the sides opposite 45 is 3 times the square root of 2 over 2, but in a 45, 45, these two guys are the same. So y here should be the same as this other leg. And so I already know right off the bat that y has to equal 3 times the square root of 2 over 2, since these two sides are automatically congruent. So this guy's taken care of. He's 3 times the square root of 2 over 2. But now I need to find my hypotenuse. So I'm going to set up my equation here. X equals whatever my leg is times the square root of 2. But wait, we found out that our leg was 3 root 2 over 2. So I'm going to come in here and replace that leg with 3 square root of 2 over 2 and multiply it there. Now all you have to do is combine everything. So I'm going to have the square root of 2 times the square root of 2 is the square root of 4. And now I can simplify. The square root of 4 here is just equal to 2. So now I have 3 times 2 divided by 2. My 2's can cancel, and x just equals 3. All right? And so you need to have this set up, and you have to know how to simplify your radicals and to multiply and divide them in order to be able to work this. Number 26. Solving for x and y, but this time instead of a 45, 45, I have a right angle, but this time I have a 60-degree angle, which means this one over here must be 30 degrees. And this is our other special right triangle, is this 30, 60, 90. So for that one, I have ratios as well, where my 30-degree, the side opposite the 30 degrees is always going to be the shortest side because it's opposite the smallest angle. Then, for the medium one that's opposite the 60-degree angle, you get this one by taking your short side times the square root of 3. Then your hypotenuse, which is opposite your right angle, is always going to be the short side times 2. Okay? And so now I can start plugging stuff in. My hypotenuse here is 16. So I can come over here and park 16 in my chart. Y is going to be the side opposite the 30-degree angle. So y is my short side, and x will be here. Okay? Well, I know from this part that the short side times 2, just the short side times 2, is 16. So if I divide that off, the short side is just going to equal 8. So I can come over here and say, great, my short side is 8. To find this guy now, my x equals my short side times the square root of 3. Well, I know that my short side is 8, so I can replace the short side, I can substitute that with 8, and oh look, now you found x. X equals 8 times the square root of 3. All right? Just keeping straight which part is which and organizing it is going to help you immensely. Don't try and do all this stuff in your head, because you're just going to mix stuff up, and then you'll be mad at yourself because you made silly mistakes. Okay? Solving for x and y again, I have a 60, a 90, so I have a 30-degree angle there. My hypotenuse is 8 times the square root of 5, and then I have my x and y. So let's set up the chart. For my 30, 60, 90, the 30-degree angle will be opposite the short side. The 60 degree will be opposite the short side times the square root of 3, and the 90 degree will be opposite the short side times 2. The hypotenuse is always twice the short side in this guy. And so now setting up, I was given that my hypotenuse was 8 times the square root of 5. The side opposite my 60 is x, and the side opposite my 30 is y. And notice how you could be tricked by that. You're going to naturally want to put x first and then y, but fill it in based on what you have here. That's a simple mistake you can avoid making by just being organized. Working this through now, I know that the short side times the square root of 2 equals 8 root 5. So I'm going to say the short side times, not times the square root of 2. That's the second time I've done that. The short side times 2 equals 8 times the square root of 5. So to get the short side by itself, I'm going to divide by 2. And the short side will equal 8 times the square root of 5 over 2. Now, I can't keep it like this because the non-radical part is a fraction that can be simplified. So I need to simplify this. 8 divided by 2 is 4. So that part becomes 4, and then the root 5 comes hanging off the end there. And so I have my short side equals 4 root 5. And that goes right there. Now to find the other one, I'm going to clear myself some space here. And again, I'm going to set up this equation. So I know that x has to equal my short side times the square root of 3. And so I'm going to replace the short side here with the short side that I just found. I just found that my short side is 4 times the square root of 5. And now I'm ready to do the work to figure out how much x is. So x will be 4 root 5 times root 3. So the root 5 times the root 3 becomes root 15, and then the 4 just hangs out in front. So x equals 4 times the square root of 15. And I'm just pulling up my papers to make sure I've done everything correctly. Okay, sorry, had to pause for a second. Now we're ready to come back. Okay, so now for number 27. Or did I just do number 27? The 8 root 5? I think we just did that one. So we're actually moving on to this guy now. So we need to solve for x and y. X is down here, and since it's off center, that tells me that it's only going to be focusing on the part of the triangle here. Why is it so dark on my head? That's weird. Okay, here, I know what to do. Get a little more of the light on here. All right? So the x is down here, the y is up here, this is 60, and this is 45, and here's my right angle. So you're going to notice right away that I have lots of stuff here, but this problem has one slight issue with it, and that is we didn't write down how long anything was on here. So you can't solve this one right now because I just flat out didn't tell you any numbers for the lengths, and I apologize for that. So you can just ignore that one and move on, unless I decide to give you a number for it. So let's make up a number for it. Okay? I think for this problem, I gave you that this side right here is 8 root 6. And for some reason, it did not show up in the picture. Okay? So if I give you that, then you're able to solve it. Okay? So let's focus on how we would do this. Since I have 2 triangles here, I'm going to focus on just one triangle at a time so that I can, not have so much to work on. So I'm going to focus on the side where I have a number I can use. And this is a 45, 45, 90 triangle. And this is the hypotenuse. So thinking back to my ratios for this, for a 45, 45, 90, I know that I'm going to have 2 legs that are the same, and then my hypotenuse will be the leg times the square root of 2. But in this case, that hypotenuse is 8 times the square root of 6. And so I'm going to have to figure out, what do I multiply by the square root of 2 to get 8 root 6? Because something just isn't adding up there. Okay, I can do this. To get my leg by itself, I'm going to divide by the root 2, and I'll end up with just the length of the leg by itself. The plain numbers stay by themselves, and then the square root of 6 divided by the square root of 2 will be the square root of 3. And so I have 8 times the square root of 3 for each of my legs, which means this is 8 root 3, and this is 8 root 3. Okay? Well, now I'm pretty much done with this triangle on the right. So I'm going to move my work out of the way and focus now on the triangle on the left. This triangle has a 60-degree angle and a 30-degree angle. And that side I just found is opposite the 30 degrees. So now this is the short side of this triangle here. Sorry for the jump cut again. Had to pause real quick and answer a phone, but I'm back. And so now let's finish up this problem. So again, think where I was that this is the short side of this triangle now. So now I'm going to start over with my ratios and focus on this left triangle, which is a 30, 60, 90. And so I know I have a 30 and a 60 and a 90 in this left triangle. I'm going to erase this stuff from the right triangle so it doesn't distract me. And I'm going to have, okay, so the 30 will always be the short side, and that's this guy. So the 30-degree angle is opposite the 8 square root of 3 that I already found. My 60-degree side will always be that short one times the square root of 3, and that is the x. And then my hypotenuse is always 2 times my short side, and that is the y. So now I'm set up and ready to go to find x and y. I am now ready to do it. And so I can go, great. I'll start with the I'll start with this guy first. So for this one, I know that x is going to equal whatever the short side is times the square root of 3. This is always the equation you're going to set up. And so you go, okay, well, I know that my short side here that I can substitute in is 8 times the square root of 3. And so I'm ready to work this now where I can go, okay, x will equal, I've got my 8, and then the square root of 3 times the square root of 3 is the square root of 9. But wait, I know what the square root of 9 is. The square root of 9 is 3. And so now x just equals 8 times 3, so x equals 24. Yay, we found one thing. Now to find y, I'm going to take 2 times whatever that short side was to get my y. Well, my short side, again, was 8 times the square root of 3. Point this back over here now. And so if I multiply this out, the whole numbers get multiplied together. So 2 times 8 is going to be 16, and then the square root of 3 comes down, and 16 root 3 is my y. Okay? And so organize, label, set things up carefully, break things down in order to solve these bigger, more complicated problems. Come here, buddy. All right. So now, solving for the missing side. Well, here, these aren't even special right triangles. These are just boring right triangles. I don't have any angles, but I do have 2 of the sides. I have 7 and 10. Anytime you have 2 sides of a right triangle, you can always find the third using your Pythagorean theorem. And so that's your a squared plus b squared equals c squared formula that you learned hopefully a couple years ago. And so you go, and earlier this year. So here, the hypotenuse, so the side opposite there, is always the one that gets c. That's the most important part you have to keep straight when you're doing these. And so you go, okay, so I'm going to have 7 squared plus 10 squared equals c squared. So this will be 49 plus 100 equals c squared. And so that's going to be 149 is c squared. I don't want c squared, though. I just want plain c. So to get the squared off of my base here, I'm going to square root both sides, and c will equal whatever the square root of 149 is. And depending on what I ask for here, I'll probably be just asking for a decimal. And so you plug this into your calculator, and you're going to get 12.2 equals c. All right? For this guy over here, turn over here, guys. I've got 5.3 and 7.2, again, in a right triangle. So if I have two sides, I can always find the third using Pythagorean theorem. But this time I have the hypotenuse. I have that side. This has to be C. And so when I set up my formula, I'm going to have to pick, I'll make this one A and this one B. I have to make sure to pick what these are and set it up in the formula in the right place. So I'm going to have 5.3 as my A squared plus my B squared equals this 7.2 squared. Okay? And so this time I'm missing a piece in the middle. And that's okay. You can solve this. And so when you work this, your 5.3 squared is going to be 28.09 plus your B squared, and your 7.2 squared is 51.84. And no, I don't know this in my head. You can see me going over there and looking at my answers. So now to solve this, I need to get B squared by itself, so I'm going to subtract off the 28.09, and B squared will equal 23.75. And then to get the squared off of here, I will square root both sides, and B is going to end up equaling 4.9. Okay? And so now I have that there. So just, again, make sure you're putting stuff in the right place when you use the Pythagorean theorem. All right, so I'm going to be pausing here, and the last part of the test will be covered in a third video where we cover trig.